All right, this is Jonathan Saran and Devin Viel, and welcome to our template method pattern presentation. So a template method pattern comes from a need to reduce duplicate code. Oftentimes there needs to be more than one implementation of an algorithm, but only certain parts of the algorithm change between implementations. Using template method pattern, you can define the non-changing or invariant steps to an algorithm in an abstract base class, and then delegate changing or variant steps to implementations of the base class. The pattern is often used in frameworks to abstract away functions of the framework from the client. The client can then implement the variant routines without having to worry about the inner workings of the framework. The framework's base class does the heavy lifting, and the client's implementation allows for customization. In this UML, you can see the invariant subroutines of the base class named framework class. First, we have a function named template method, which will be called on each of the application class instances. And also you have functions step 1 and step 3, which are invariant, non-changing methods placed here to avoid duplicate code. The variant routines are defined in each implementation. In this case, it's just a function named step 2. An example more pertinent to our stockpile app would be a sorting algorithm that would sort pantry items by different properties and in different ways. The UML here shows the sort method that would be called on each instance of an implementation of the base class, and the compare method is redefined in each inheritance class, and the unchanging parts of the sort algorithm are written in the base class. To get an idea of how this looks, we'd like to show you two examples. One of which is more simple, and we'll show another one more relevant to the stockpile app. So here we have kind of the simpler version, a class named person. Introduce will be called on in each instance of a declared person. And then you have invariant methods, say hi, which just says hi, say beginning, my name is, and then the variant method, which will be implemented in each inheritance class. John says John, and Devin says Devin. So if we run that, we see each of these. And the cool thing about having the invariant methods in one class is if you go to change it and like you want it to say hello, you can do that, and it changes how each of those inheritance classes works. So now here's a more complex version of that. That would be used in our stockpile app. We have items here, an array of items. Each one has a property name and price that we can sort by. Here's our base class, which has a sort method. We'll call that on each of our instances of one of these inheritance classes. And then a compare. This is just a placeholder here, and we implement this method in each of our inheritance classes. So here's one that sorts by price, the compare method there, and another one that sorts by name. If we run that, but okay. All right, we have upsides.
So there are quite a few upsides to using the template method. Some of the upsides that using this method brings to the table are it can easily be extended. So if you have a situation where you're not sure where the project's going to go, or there might be more inheritance classes that you want to add on later, this is an easy way to do that, where you set up your base class and then you can add on more as time goes on, or just leave your project open-ended. And frequently, when people want to add more functionality to a project, the base class needs to be updated to allow the changes to take effect. In the template method, the base class will always remain unchanged, so that the same process is followed every time. That's a fairly big upside to when you're using a complex process. And then one of the most frequent and consistent benefits to using the template method is that the base class being invariant, you can repeat code as often as needed. So this allows you to make changes only to the inheritant classes, saving the programmer the need to repeat code multiple times for similar functions. So the fact that it's separated lets you have the ability to add on to it without having to make lots of changes every time you do want to add something to your program. And then that will lead into what are the downsides of the program? So, or this method rather. So one of the largest upsides is also one of the largest downsides. So due to the fact that the base class is designed to not be changed, in the event that a change does need to be made, it can cause unforeseen problems and be difficult to reconcile down the road. And so one of the reasons that it is difficult to reconcile is because the inheritance classes are so variable that it can be difficult to know what exactly the program is doing. The sequence flow of the program can be more convoluted than a traditional method when using the template method. And so due to the fact that it can get pretty muddled quickly, when unforeseen changes are implemented, the programmer needs to provide as much documentation as possible. Along with documentation, error handling needs to be very strict as well in order to prevent any problems. And so that's going to take more time from the programmer. So because it is kind of operating on its own, it does require more documentation from us to make sure that if a change ever does need to be made, we know exactly how that's going to affect the entire project. And then moving on to the recommendations, this template method can be used very well when it's used for building frameworks. So due to the fact that inheritance classes can be somewhat vague, it makes the base class the main architect function as placeholders for future growth. So that's perfect for building frameworks when you just are using general ideas. And then also auto-generated code is another place where the template method not only is good practice, but it probably should be used. And that's due to the fact that since the code was generated instead of written by an individual or team, that changing it could cause unforeseen problems. So it's best to use auto-generated code in the template method so that it can be added to but not altered in the future. And then another time that the template method would be especially useful is when a project is being built that could potentially grow. Similar to how we mentioned earlier, this again builds on the idea that the main parts of the project will stay the same, but individual sections can be grown to match new ideas. For example, in the context of our pantry project, if we potentially wanted to provide the user a way to sort products in a different manner, but we weren't sure what that was yet, the template method could allow for future growth, as shown in the previous example that we put up on how it sorts things. And to be fair to the template method, it's not you have to use this over another. Frequently, they are used together, but these are the times when it would be best appropriate to use the template method.
All right, and there we got our sources there. And this here, it turns out that it was just being slow. Here we get our output, and you can see the sorted objects there. All right, thank you for watching.